Now we will discuss about a small problem whatever we discussed previously or the theory part of the bolt design. So in our problem that you can see here, calculate the strength of the bolt, diameter of 20 mm and the grade is 4.6 and the plate thickness is the 12 mm. This much is our main problem. So first of all, how could we solve that in the help of the code and the calculator? So first of all, step 1, follow that part we mark as the step 1. It will be very easy to solve when you are marking the step 1, step 2, step 3 like that way, and it will be very easy to examiner also to evaluate your copy. So in step 1 we will write here the given data. What is the given data? The D0, that is given. We can calculate from here DH, FUB, FU, gamma MB, ANB, that much, and here also T as well as. So what is that D0? That is our bolt diameter, that is 20 mm, right? What is that DH? As per our previous formula, we should add on plus 2, that means 22 mm. What is that FUB? That means the tensile stress of the bolt, that is 400 MPa. What is that FU? That should be the 410 MPa. What is that gamma MB? That is the value of 1.25. That is the partial safety factor, so it is the unitless. What is that ANB? Tensile stress area for 20 mm bolt diameter. So as per the calculation, you can assume at 245 mm square, and the T, the value of the T is 12 mm. So that much is our given. From here we can easily jump to the step of step 2. So what is that step 2? First of all, any design regarding steel structure we have to follow one code, IS 800 2007. That is the preliminary IS code. From this IS code, page number 75, here you can see that the step 2, that means that the shear capacity of bolt, that is our step 2. So what is that step 2 of the shear capacity? There is this formula VDSB by gamma MB, which is equal to VNSB. That is the formula. So VNSB, which is equal to VDSB by gamma MB. What is that the VDSB? I am clearing from that part. VNSB equals to VDSB by gamma MB. What is that VDSB? FUB by root 3 NN into ANB by gamma MB. For the calculation purpose, you should have to remind as it is into 10 to the power minus 3 kilonewton. Just because of we are calculating shear capacity, so the unit should be in kilonewton. Put all the values, that means 400 by root 3 NN, that means the shear plane. So this problem is the no shear plane ki both shear plane, nothing. Nothing is given, that means the number of shear plane is calculated as 1. What is that A and B? 245 by 1.25 into 10 to the power minus 3. After calculating all those things, you will get the value of 45.26 kilonewton. Step 2 is complete. Now, for our design, we have to another step. You can see here the bearing capacity of the bolt. That is our last step. Step 3. Shear capacity is already calculated. That means the step 3 is bearing capacity. VDPB is equals to VNPB by gamma MB. So what is that VNPB by gamma MB? That part is the formulation of 2.5 kb D0 T into FUB. So you can see here 2.5, that is calculated. D0 already we have the value. T we already have the value. FUB we have the values. What is unknown here only? That is only KB. So what is that KB? KB is equals to E by 3d0, comma P by 3d0 minus 1.25, FUB by FU in and 1. That means that is the formulation of E by 3d0, P by 3d0 minus 1.25. Just a small P by 3d0 in minus 1 minus 1, FUB by FU and 1. So from here also you can see what is that E and what is the P. E is the small thing which is called as edge distance. So what is that edge distance? From that part, if we consider that is the whole plate, from that portion of our fast bolting, if we consider that is point is the fast bolting, that distance is called as E. That means edge distance. Now what is that P? P is called as the pitch distance. That means if that is the fast bolting, that is the second bolting. So the distance between the two consecutive bolt from center to center distance, that is called C by C distance, that is called as a pitch distance. So there is a formula. If we calculate that FUB by FU, you will get the value 0.975, just because of if you calculate 400 by 410, it will be calculated at 0.975. Clear? After putting all those values, we will get the value of KB is equals to 0.55. After evaluating all those values, which value we should take? Sir, we will get 1 value, 2 value, 3 value, 4 values. Which value we should take? The minimum one. The minimum one we should have to take. After putting all these values, then you can calculate 2.5 into KB 0.55 into D0, that is 20, T, our thickness was 12, FUB, that was 400, divided by 1.25, that is the gamma MB factor of safety, partial safety factor you can say also, into 10 to the power minus 3. After evaluating all those formulas, you will get the value of 105.6 kilonewton. So step 1, that is given data. Step 2, that is our shear capacity, and step 3, that is our bearing capacity calculated, done. So sir, this much is the problem? Yes, that much is completed. What will be the answer? Calculate the strength of the bolt. So how could we finalize what will be the strength of the bolt? Here maximum student does the mistake. How? Sir, the calculated value is 105.6 kilonewton, that much is the maximum. So this much is the strength of the bolt. No. From that the design of bolt calculation, whatever is the minimum in between the step 2 and step 3, I am just repeating another time, step 2 and step 3, whatever is the minimum in step 2 and step 3, whatever is the minimum 45.26 and 105.6, both are in kilonewton. Whichever is minimum, that is your strength of the bolt. That means 45.26, that is our answer. It's simple problem. It will come around 10 marks or it may be 8 marks. Thank you.